Okay, now here I'm going to clone dash, which again is just a fork of Bitcore, and I'm giving it depth 1, so it does a shallow clone, so it's not going to take forever to download the whole thing. It's just going to download the most recent. And then I'm going to run autogen and then configure without the GUI, because that would just take even more time. That would just be obnoxious, and we don't need it for a full node that's not on a desktop. Well, not that you'd have. I think the dash is only around like 12 gigs or so right now, so it's not too bad. But most of these chains, you can't even fit them on your laptop anymore. And now you'll notice in the instructions, I keep on putting just make, and then I keep on typing out -J and the number of cores. And the reason that I didn't put that in the instructions, this is important, is that if you don't have enough RAM, you get really weird random errors that when you Google will mean nothing, because you'll get an error about something failing to compile. You'll go Google, why isn't this compiling? And there's no reason. The reason is just because you ran out of RAM and there was a compiler error and it died. So doing one thing at a time with 2 gigs of swap works even on a 512 megabyte system. It works even on a Raspberry Pi much of the time. I actually found on a Raspberry Pi I have to redo the process a few times for some things, and it'll randomly die, but then it will work. Maybe I need to increase the swap or something. There's probably something I could do that would help that. But so on this system where I know that I've got plenty of RAM and plenty of swap, I'm not worried. So I'll let it do 6 things at a time on every core, and it works. So this process here, it normally takes around 20 minutes. I think with the 6 cores, it might only take 3. Yeah, so that only took about 2.5 minutes in real time. Now, one other note I'd like to make. So here I'm doing without GUI to speed things up, because adding the GUI would take even more time, right? I've tried subtracting other things, like for example, when I'm just using it for RPC and API, I don't need the wallet. But what I've found is that with some of the configurations of -- without, the compile doesn't finish successfully. Those things may have been fixed, but at the time I was going through it, it didn't work. So that's why I'm only disabling the GUI, because that's the configuration I found that would still work. If those problems are still around and the -- without -wallet, for example, causes an error, it should be very easy to detect that that's what it is, because it'll be, it'll get somewhere along not in the wallet and then complain about a wallet file not being available. So just somewhere where it shouldn't even be using the dependency set still happens to be referenced, not a big deal. But that is why I, even for just an RPC API server, I have it installing so much. All right, and then I'm going to get out of here, and I think we're almost ready to test. So I'll go ahead and turn off the swap, remove the swap file, and then go back to the directory from which I came. And, I need to take this step out. So this in the latest version is no longer used. Basically, what I like to do for creating a random password, because this is what you need to do, is you need to edit opt-pay etc-conf. Okay. Yeah, there's nothing included by default. So let me go take a look back over here at the repository. I am gonna come back and review that shell script. I'm gonna come back here. I'm just gonna copy out of this -- and so I've got my user as dash, and what I like to do for creating a password is I just use Node. I think there's something similar in Python and other ones, so maybe for your favorite scripting language. But I do crypto.randombytes.toString hex. Oops, I quoted the number. There we go. And then that's the AJ quick and dirty way of creating a password. So got that done. Again, I'm going to go back and we're going to talk about that install script and some of the differences between that and this in a minute. Oh, I had it right here. So supposedly this was the old way. and this was the new way, but since that Python script that generates the hash, and I'm not sure which algorithm it uses and whatnot to do that, but since that has been done away with, I am doing it the old way, and we can name it whatever we want. I think in other places it just needs to match whatever your username and your password is. They just need to match in the other places that you use it when you connect to the RPC and whatnot. Also here you'll notice the whitelist is 0000. I probably should update that. You want to change it to 0.0.0.0 once you are ready to make the system publicly accessible to the outside world. If you're doing your RPC and your API calls locally, then you should just leave it 127.0.0.1 so that no outside attacker could even get access to it. So next what we're going to do is I'm going to run, this is not in my path, so I can't just type -d. I got to give it the full path. I'm going to run -d. I'm going to give it the comp file that I just created. And then the data dir that I'm going to give it, this is where the blockchain's actually going to go, and the caches and the indexes, etc., is var. So now I'm just going to run that, and I think in a minute or so it's going to output some messages, but essentially this is now going to start downloading the blockchain, and that will probably, depending on which blockchain you're doing, will probably take several hours. And Dash, like I said, I think it's about 12 gigs, so you can figure out what your connection speed is and do the math, but this is the kind of thing that you just kind of let it wait for a little bit. And then I go on to describe most Linux systems use systemd, so you can basically just copy and paste this into the etc systemd location, and then when you restart the computer, it'll start automatically as a service, and then you can use the daemon reload, enable, disable, start, journal control to watch it, etc. And you'll have a full Dash node running. So now that that's running, let me just show you a couple things. First, I'm going to hit Control-A-C to create a new screen. So that one's still running. If I hit Control-A-N, you can see it's still running. So this is kind of like a poor man's way to daemonize a process. So if I go into, let's just take a look at what it's downloading. So before, -pay var was an empty location. Now you can see it's begun to download the blockchain. If we look in database, you can see it's got a few things going there. We can see, I think also in var, it has the debug log. So shows that it's running, that it's beginning to sync. Another fun thing that you'll probably find useful is the -CLI. Oops, that's not what I meant to do. I did not mean to vim that. Oh, and by the way, I'm hitting Control-A and Control-E to get to the beginning and end of lines. That's an old Emacs thing, but it's carried forward into most shells. No authentication could be found. Okay, so I need to put my authentication details in my home folder here. So I'm just going to go ahead and copy those from opt -pay etc dash.conf RPC user RPC password, and then put it here in my local directory. Try that again. And then sometimes when it's early on, it'll give an error that it can't do anything because it can't connect yet because it's loading indexes or something like that. You can just ignore that, wait 30 seconds and try again. So I'm going to try, let's see. There's a fun one here. Let's do get peer info. Let's see information about peers that we're connected to. I think it gives back a bunch of JSON if I remember correctly. So it's going out to the network, making some requests, asking some questions. Okay, so that took about 20 seconds or so. But here we are. Here's a bunch of information about, I guess, peers we're connected to. There's some other stuff that's kind of fun that we could poke around at, but I just wanted to show you that we do have a master node. And then I actually will go ahead and create this service just to make sure that things are as I believe that they ought to be. So I'm going to go under systemd under Etsy, and then under system, and then we'll just call it -g.service. I don't really want to teach you about systemd. You can learn it on your own, look in the comments and stuff. But essentially, there's a couple of those environment variables that I use. I think I might be able to forego them now, because I think I used these before because I didn't specify them while compiling, and so there was some trouble finding them. But I'm going to leave them in there. But I think they're superfluous. I don't think they're necessary once I finally nailed the compile step. Yeah, and then this is what we're running in the other window right now, is that right there. So, I don't know. Systemd is kind of complex. I don't want to talk about it too much, but the important thing is that everything happens in op-pay. That needs to be set as a read-write directory if the system's being protected. So this protection stuff just makes it so that only reads and writes can be done by -pay in that directory. And then I think the user and the group are -pay, so we're going to have to create that user and group before this will work. So that's a pretty simple process. So we're just going to add this user with no password so that it can't log in, and then make the op-pay directory owned by the user -pay. And then we're going to reload the system daemon. Basically, anytime you make a change to any files in Etsy systemd, you need to do a daemon reload. I'm going to go ahead and quit this, and it's going to take a second. It's not going to immediately quit because it's doing some cleanup so that nothing breaks. And then I'm going to say we're going to enable -d, and then let's go ahead and I prefer to use restart than start. It doesn't look like that gave us any errors, and if we're lucky, we should be able to see the log status simply shows that it's running, and if there were any output logs, then we would see those as well. So now this whole thing is set up. You've got a -full node running, and again, if you're doing Bitcoin or Litecoin or something else, you're just going to need to change a few things, predominantly where you do your git clone from, and that would work as well. I'm a little partial to Dash. I think that the system that they have is a little bit smarter in terms of how the community is managed and some of their code choices. But I don't want to be prejudiced or anything. Anyway, here you can see. I didn't define a environment variable, so you can set -num CPUs and it will do the -j. It looks like in here. So this is the script is just all the things we went through, just a little more confusing because there's more environment variables used. So if you wanted to go in here and change something, if you're not on a Debian system, this is the part of the script that you'd need to change. There were some things I left notes and kind of commented out in here. I probably should just take those out. I don't recommend doing it. So go into a temporary directory, grab all the stuff, compile it, get out of the temporary directory, turn the swap off, create the user, copy over the -d service, reload the daemon, start it. So yeah, I think everything that we went through over there, I don't think there's any difference between that and the script other than a few variables that are extra. So hopefully that is useful to you. If it is, go ahead and give us a little star there on GitHub. This is Dash Hive.